tan of some angle. Those are very difficult, right?
Yes, sir.
Yes, sir. Yes, sir.
Yes, right? Now, the C program, that is the compiler, has something called as the built-in functions. Something called as a built-in functions. Okay, built-in functions. Like some examples we have already seen. Printf is a function. How I can say a function? Because I can see here a pair of brackets, open and close bracket, right? There is something called as a scanf. Okay, this is also one of the function. Apart from these two, do you remember any other function so far we have discussed, which you have encountered so far? Any other function?
Main function.
Very good.
Main function.
This is what I was looking for. Main function. Whenever you write void main, that main is what? It is a function. Because after this main word, there is an open and close bracket. That means it is a function, right? So all these are what? These are predefined or built in. We call them as predefined. Okay, predefined. Predefined means already these functions are there in the compiler. They do certain tasks. Certain task in the means was the printf, what it does, it will print on monitor. Same way, scanf, what it does, it reads from keyboard, right? Then what is this main? Main, start of execution. Start of program execution. So all these are what? Predefined functions. Like the same way, there is another set of predefined functions which usually we call it as mathematical functions, which are called as mathematical functions. Okay, now I have told you that these functions, the one which I have highlighted here, these are already present in one of the header file called as what? In which particular header file these functions are present? In which header file three functions are present? What is the first statement you write?
Include stdio.h.
In that, what is the name of the header file?
Standard input
io.h. stdio.h is what? It is a header file. It is a header file. In this header file, okay, these functions are okay. The reason being why we write this statement, hash include stdio.h. Okay, why we write this one? Because in our program, we are going to make use of these functions, and these functions are present where? These functions are present in this header file. Okay, since these are present in this header file, I'm including those header files in the program. That is the meaning of this statement, hash include stdio.h. It's just a repetition for you students. I have already explained this one. Okay, what is the meaning of this hash include stdio.h? Means stdio.h is what? It is a one of the header file. Why we are including this one? Because in the program, we might be using printf statements, scanf functions, or the main functions. All these are present where? These are present in the stdio.h header file. That's why we are including them. In the same way, there are something called as a mathematical functions. These are also predefined functions. They are also present in one of the header file. Okay, and we will discuss on that header file and followed by the name of the functions in the next class. Okay, so we were discussing yesterday based on some certain built-in functions. So built-in functions, basically, as I said, built-in functions are the functions which are already there in the C compiler. Okay, like the functions such as printf, scanf, and the main function. All these are present in the header file called as a stdio.h. Right? That's the reason. Suppose if you look into any one of our programs, any of the programs. Okay, let me take off these things. Okay, let's go to another file. Now, what I will do here, I will try to demonstrate if you don't include what these header files, what will happen. Okay. Now, first statement, obviously we write that hash include stdio.h. Okay, and then we write void main. Okay, and then say a simple printf statement, say printf, okay, welcome. Okay, it's just simple one statement I'm printing here on the screen. Save the program. Okay, and let me give the name as library functions dot c. Okay, now if I execute this program, let's see the output. GCC, then the file name is library functions dot c. Okay, there are certain errors here. What are the errors? Line number 5. Line number 5, there is a slash missing, n is missing. Okay, I added that one. No errors, and when you run, get this output. Okay, now pay attention. Now I'm removing the first line from this one. I have not written the hash include statement. Okay, stdio.h I have not included. Now I'm compiling the program. Okay, now do you see these errors? Basically, these are not errors. What we are getting the warnings, right? See this printf, okay, all these are not being incompatible. It is not going to print the statements properly. And you see a note here on the bottom line. It says note include stdio.h or provide a declaration of printf statement. It is telling that this printf is not able to be identified where it is, which one printf you're talking about. Okay, it is telling you the one suggestion that you may need to write this hash include statement where you are going to include stdio.h. Okay, so now if we include those particular part hash include stdio.h, then definitely that warnings and errors will be disappearing and the program will be able to execute. Okay, this is the use of the built-in library functions. Okay, so we were discussing upon certain mathematical functions. Okay, there are few mathematical functions. There are many mathematical functions. Out of that few I will explain over here. In order to use the mathematical functions, there is another header file by the name math.h. Okay, remember there is one mathematical header file called as math.h. Now, if you just read through this one, how to understand this? See, math.h. .h means what? It is a header file, right? So header file for what purpose? For performing the mathematical operations. Okay, there are certain functions, library functions. Those library functions are placed where in the mathematical, that is math.h header file, and I'm including that file in this program. Okay, now you may ask, sir, what are the different mathematical functions? Okay, suppose if you are writing a program and you want to calculate, say, a square root of a given number. Okay, you want to calculate a square root of a given number. Let us say take int, okay, say 25. I want to calculate the square root of this 25. Okay, then how I can do? I can make use of, there is function by the name sqrt. Okay, so this sqrt is a function. What type of function? It is a library function. If we categorize, it is a mathematical library function which is placed in the math.h header file. What it does, okay, it accepts one particular value. We call it to be a argument or the parameter. Some new word you are hearing here. See, argument or parameter. So this argument or parameter is something which we provide to the function. Now you notice here, there is a function here. How I can say this is a function? Because there is one name followed by open and close bracket. Means this is a function. This function accepts or takes one argument. Say if I use a variable here, say int I equals to 25. Then if I type here I, what is going to happen? This I values square root, this particular function is going to be calculated and that value will be stored in another variable. Okay, for that particular purpose, what I will do, I will declare a float number because the return, it is the sqrt is going to return a floating point number. So float, say result, float result. Okay, this result equal to sqrt of I. Now understand this statement here, how it works. Okay, now res is equals to sqrt of I. So equals to means what? It is an assignment operator. We are assigning some value here. What value we are assigning? Based upon this sqrt I, right? Sqrt of I means what? Sqrt means square root. Square root of what? Square root of I we are going to calculate. So who will basically calculate this value, square root? This will be done by the built-in function called as sqrt. Right, that square root function will be called, which is placed in this header file, that is math.h, and it will give the result. That result I'm going to store into another variable by the name res here. And if I want to print that one, what I can write? I can write a printf statement. Printf, okay, square root is equals to, okay, percentage f slash n double quote complete and result. Okay, now how this printf will be executed? It will display square root equals to, and percentage f means it is a format specifier for floating point numbers, that is result. Result is a variable of float number, so we are using percentage f here. Okay, now let us run the program and check what result we get it over here. Now compile the program, no errors, run the program. Now what I get here, this welcome was already there, and then square root is equals to 5.000. So how this 5.00 got displayed? Because we are using a library function by the name sqrt. This sqrt will calculate the given values, whatever value we pass, this particular variable values, square root it is going to calculate. Or suppose we may write in this fashion also. Okay, I'm just using the same variable, result is equals to sqrt of, say, we want to calculate the square root of 124. Okay, it is not a perfect value. We don't get an integer value. It will be some random number, right? A fractional number. So I'm just printing the same thing. I want to calculate the square root of 124. So directly 124 I can write here within the its brackets, sqrt functions brackets. Then I am printing the result over here. Now let me take off this printf statement at the beginning. I don't need this. Save the program, go to the terminal and compile first and then execute. Now you see here, first one square root of 25 got displayed, then next time square root of 124 it got displayed. Now, do you find that these library functions, especially the mathematical library functions, are very easy for us to use? Whenever a program requires certain type of mathematical operations like sqrt, we can make use of. Okay, there is another mathematical function which will calculate the power of two numbers. Power of two numbers means, suppose if you want to calculate 3 raised to 5, right? 3 raised to 5 means what? What is the value of, say, let me take a simple example. What is 2 raised to 3?
8.
8, right? 2 has to be multiplied 3 times. So we are going to calculate the power of a given number, right? So in order to support that one, there is another mathematical function, okay, called as POW. Okay, see here how easy to remember these are. POW, POW, that is power. First 3 characters are used here. Power, right? Power means definitely I require how many numbers? 2 numbers, base and the exponent, right? Suppose if I want to calculate 2 raised to 3, say that has to be written as 2, 3. 2, 3 means what here for the power function? 2 raised to 3. So that result I will get, that result I will store into one variable and then I will print that value. Okay, let's use this one, and here I will change to be power of, or let me write like this, 2 raised to 3 is equals to. Okay, now run the program and check the values. Now 2 raised to 3 is 8. You can take any numbers. You can take any number. Suppose if you write, if we copy these 2 lines, say 5 raised to 4. 5 raised to 4. So what I'm going to calculate here, I'm passing two parameters or two arguments. First argument is what? Phi. That means it is the base. Second argument or second number or the parameter is what? 4. That means exponential term. Phi raised to 4 will be calculated by this POW function. And the result we get to see in the printf over here, right? 625. Are you following these mathematical functions, students?
Yes, sir.
Yes, sir.
Okay. Yes.
Yes, sir.
There are some more mathematical functions for trigonometric functions, right? Trigonometric, in a mathematics, trigonometry you might have studied about sine, cos, tan, cot, right? Sec and cosec, isn't it?
Yes,
These are the trigonometric functions, right? Then if we want to calculate a particular any particular values of our trigonometric functions, then there are corresponding built-in functions or library functions we can make use of. Okay, now when we discuss about trigonometric, there comes something called as the values in terms of angles and radians, isn't it? A trigonometric functions
Yes,
can
sir.
take the values in terms of angles and radians, correct? Now there must be a standard formula to convert angles into a radians and all. Do you remember? Anybody knows those formula? Sir, you are asking very difficult question. Now we have already passed the 12th PU, see 12th, that is PU plus 2. That was very difficult for us to remember those formulas. Now again you are asking the same questions. Is it difficult to answer?
Theta into plus or tan plus or minus is equal to something, sir.
Okay, let's see here. Okay, now there are functions here, functions. Okay, let me comment these lines. Okay, now there is a function called as sine. Okay, SIN. SIN is a sine function. Okay, what it does, it gives the values. Okay, a result of a sine value, whatever we provide over here. Okay, now as you know, values can be in terms of angles or it can be in terms of radians. But these mathematical functions are designed, okay, such a way that it only accepts the radian values. It won't accept the angle values. Whatever the value you provide here, it will be treated as radian values. Okay, now then you may ask a question, sir, how we need to convert these angles into a radians? So we might be interested in what? Say what will be the value of sine of 90 degrees. This 90 is what in terms of degrees?
Into pi by 1,
90
sir.
degrees. I want to calculate the sine of 90 degrees, but this 90 won't be accepted by the sine function. It will only accept in terms of radians. Then we need to convert that degrees into a radians. So
Degree into pi by
is equals to how you calculate in terms of radians if a given angle is given.
Theta into 180.
If angle, say angle is equals to 90 degrees, you want to convert this angle 90 degrees into a radians, then the formula is what? Is that correct?
angle into pi by 1.
Correct. Angle into
Pi by 180.
divided by 180.
180.
Right? Pi by 180 multiplied by the given angle that has to be worked upon. Right? So now for that particular purpose, what I will do, I will make use of certain variables here. Say float, say angle. I will write ang as for the angle, then radian. Okay, and already result we do have there. And also we require a pi value. That pi value I will define it to be a constant. So hash define pi 3.142. Okay, I have defined as a constant value. Okay, then in the program, what I will do, say angle is equals to 90 here. This 90 means what actually? This is a, what
Degree.
this 90 means?
Sine 90.
Degrees, right?
Sine
This is going to be degrees, right? So let me make it further simpler actually, students, for your purpose. Radian is equals to the angle. Suppose sine of 90 we want to calculate, 90 I will type. Then the formula is 90 into pi divided by 180. So what this formula is? Convert from angle
And
to
radian.
radians. So here angle 90 is the angle, okay, and pi is a pi value 3.142, which we have defined in the constant, and then the 180 divided by 180 value. Now, if I write a statement like this, result is equals to, okay, then sine of rad. So what it means, we are passing a radian value, the converted radian value, okay, and we are interested to find out sine of 90. So sine of 90, first what we did, we first converted that 90 degrees into the what, the radians, and that radians I am passing into the sine function. This is sine function is what? It is a library function, built-in function present in the math.header file. And then later let us print the value of the result. So print f double quote. So here let me write it as sine of 90 degrees. Sine of 90 degrees is equals to percentage slash n double quote complete, then res. Okay, let us see here what value we will get here. Okay, then let me clear the screen. Okay, compile the program. Then okay, there are no errors. Then execute it. So look at the last printf statement here. Sine of 90 degrees is what? 1.00. Is that sine 90 is 1? Is that correct?
Yes, sir.
Yes, right? Now, suppose if you want to calculate some other angle, okay, if I want to calculate the sine of 45, okay, I will change the value here to 45. Similarly, I will mention it as sine of 45. Okay, sine of 45. Let us see what we get the value here.
1 by root 2.
1 by root
1 by
Root 2.
root 2. So 1 by root 2 is while writing the solving on a paper, we use 1 by root 2. But 1 by root 2 value is what? 0.707179. Can anybody confirm me that this is the correct value? 1 by root 2? Now you may ask, sir, shall we do it in the program itself? Shall we do it in program itself? For that, what I will do, 1 by root 2 we want to calculate, right? So I will use one more variable. Okay, let me use one more variable here. R. Okay, then I will calculate that 1 by root 2 here. R is equals to 1 divided by square root of 2 I want, right? So square root of 2, there is a function already, mathematical function. What is the name? SQRT, right? Square root of 2 I want to calculate. And then display that value. Print f. Okay, then 1 by SQRT, okay, of 2 is going to be what I'm going to print here. Square root of 2 is equals to percentage f slash n double quote complete, then r I will use. Okay, then let us check here how much we get. Is that same values or different values? Almost approximately both are same, right? 0.70179, 0.70170. Is that correct?
Yes, sir.
Okay, I will just brief you what I did here. Here we calculated the sine of a given degree. Angle we cannot pass to the sine function. Instead of that, what we need to do, we need to convert into a radians. So we converted into a radians using this formula. Radians is equals to angle multiplied by pi divided by 180. Pi is what? 3.142. The constant we have defined here. Okay, then later we called sine function. Okay, we are using the sine function. What it will do, it will return us the value, okay, which we pass in terms of radians. Okay, then that result we are storing in a res variable. So sine of 45, calculated and it gave us a result. Okay, then we know that sine of 45 is what? 1 divided by square root of 2. Right, 1 divided by square root of 2. So we wanted to calculate 1 divided by square root of 2 also. For that purpose, I use another mathematical function, SQRT. So 1 divided by SQRT of 2. So the result I stored in R. Now I will compare this RES with R, whether both are correct or different. Okay, for that purpose, I run the program and I got these values. So sine of 45 degree is 0.707179 and 1 by square root of 2 is this one. Both are, I cannot say equal because sixth digit here is changing, but approximately both are same. Is that understood, students?
Yes, sir.
Right?
Yes,
so
sir.
similarly, sine we have a function. Similarly, we do have the functions for cos. We do have the functions for tan. Okay, like the different trigonometric functions are available in the math.header file. Only thing is that whenever we want to use these mathematical functions, including that math.h file is a must. If we don't do, what will happen? Let us see that also. I'm removing, I just removed, that is deleted the math.h header file. And now if I compile the program, okay, let's clear the screen. If I compile the program, see here, we are getting all these warnings. It says SQRT, power, sine, right? These are not there. Okay, and it also gives us a hint that, okay, include math.h provide. This include this math.h in the function in the program. So if we include that one, include, right? Okay. Run the program, this time compile the program and all those errors will not be seen. Okay. Any doubts, students, here? Are there any doubts, students?
So I have a doubt.
Yes, go ahead, miss.
When we were doing the previous programs like simple addition, multiplication, and all, the previous one, that time we didn't put this thing, sir, include maths thing. But then still it was processing, it was still compiling. And why
Yeah.
only for this?
Okay, why only for this? Yes, very good question. Now here we were doing what? Say C is equal, or say R is equals to A plus B, right? So here A plus B is what? Simple arithmetic operation. In order to process this A plus B, this plus whatever operation we are using here, this plus is already known by whom? Known by the stdio.h. Okay, this A plus B, A minus B, or modulus operation, less than operation, greater than operation, all are known by this stdio.h itself. Okay, but here we are using, in order to calculate the square root, we are using SQRT. This SQRT is something different, right? This SQRT will not be recognized by this stdio.h. So in order to recognize this SQRT, the corresponding header file is what? The math.h is the one. So we need to write this math.h. If I don't write this math.h, then that will not be identified. Okay, these are the additional parts. It is using, see, when we look at here, see this function, this operation, the addition is, say, fundamental operation. All these fundamental operations are present over here. But when you look at this SQRT, that is square root is not a fundamental operation here. Okay, it in turn having some different activities. It in turn has certain operations to be performed. Those statements are present in this SQRT. Okay, this SQRT function in turn is present in the math.h header file. That's why we are including this one. Okay, if suppose if this SQRT is present in the stdio.h, then we need not include. But here this SQRT function is present in the math.h header file, so we are including it.
Okay.
Okay, does that answer your question?
Yes, sir.
Okay.
Thank you.
Any other doubts, students? It calculates raised to operation. First number raised to second number. Okay, so these things we had studied in our yesterday's class. Are there any questions related to that? Any doubts? If there are, you are free to ask now. If there are no questions, so we will proceed with the today's session.
Sir, I have a doubt.
Yeah, go ahead.
We gave two comments yesterday, that is argument and parameter. What they mean?
Yeah, I will explain that now. Okay. Right. Okay. Now here comes it. So this is something we are talking about, a function. This is the name of the function sqrt, and we are passing certain numbers over here. Okay. So arguments and parameter means, now in order to perform, say now if I want to calculate the square root of a given number, okay, then that number I have to provide it to this sqrt. Okay, try to something do that. Try to think in this particular fashion. Now, suppose at your home, I'm just giving a simple analogy over here. Okay, now at your home, suppose if your father or a mother ask you to bring certain materials, say some rations from the any of the shopping mart. What do you expect? You expect your father or mother to give certain money to you. Then only you can bring those materials, right? If unless and until someone provides you the money, you can't buy any, you can't purchase any of the goods, right? In the same way, if I want to calculate the square root, I need to provide certain things to it. What is that thing? That we call it to be an argument or the parameter. This argument or parameters are nothing but this can be a constant values like this. See that this is 124 is the value I am passing. I want to calculate the square root of a given number. That number I have to provide it to the given function here. So that particular value what I am passing here is called as argument or the parameter. Okay. In the other example over here, you may see instead of giving the direct value, I am providing a variable here. Right? So we can pass the variables to the function, or even we can pass the numbers, the values also we can pass. Not only numbers, we can pass any of the constant numbers we can pass. Okay. So these things we call it to be arguments or the parameters. Okay. In a standard way, we can say that if a function accepts in the sense within the bracket, if something is there. Okay. If a function accepts any variable or any constants, then such a function or such numbers or the variables, we call it to be arguments or parameters. Based upon this value what we have passed, this function will be doing certain activity based upon whatever it is being defined for. In this case, sqrt, if you notice here, it takes only one argument. So we are passing only one argument. In the second case, the power function, if you notice here, within the bracket, two values are given, separated by comma here. That is something you need to notice here, separated by comma. So what does it indicate? Okay, since this brackets, within the bracket, it is not empty, means it is taking certain argument or the parameters. How many? Two. Why only two? Because we want to calculate the power. Power means what? First number, that is base raised to the exponents. So base and exponent, two parts we need to pass. So that two parts I am passing over here. These are two mandatory things. This, if I provide these arguments, then only this function is going to, or it is capable of calculating the power function. If I don't provide the second part, it will give us an error. It will give us an error. Let us see that what error it gives. Okay. Since power function, we require two arguments or the parameters. And if I am not passing those things, then what will happen? Okay, let us see it. GCC library function is the name of the file. Okay, some variables I have not declared here. Okay, I think this is the part. Let me remove this one first. Okay, let us check now. Clear. Okay, now look at here the error. Line number 21. See, in the library functions.c, line number 21, there is a error. Okay, what it says, too few arguments to the function pow. So too few arguments means what? If you go to line number 21, so here it is, line number 21 is here. So what it is telling is that too few arguments. Too few argument means it accepts, it requires 2 arguments, but what are we passing here? We are passing only 1 argument. That's why the power function is not capable of calculating the power of the given numbers. In order to do that one, we minimum require, that is we require exactly the 2 number of arguments. So these are called as the arguments. And now this time if we compile, then definitely there will not be any errors.